continue with our learning Erlang. We're reading out of this book, Learn You Some Erlang for Great Good. Um, and we've been going through the book. This is probably like part, let me see, 1, 2, 3, 4, 5, 6, 7, 8. This is part 9. We're like getting pretty far ahead. But the book has like 20 something chapters, so we're not even midway through. But I think we're having fun. I'm enjoying doing the Erlang stuff. Um, it's not like a language where I have a project in mind already. Usually, I think that's well, no, I wouldn't say I always have that, but like, so it makes it a little harder to really attach myself to it right now. But um, but it's still fun. So let's switch over and get started right away. Actually, here we go. This is the book. You can see here, Learn You Some Erlang for Great Good. This table of contents. This book is free, available online. You can see my playlist for Erlang on YouTube and see all the previous videos there. And it has a link in my previous videos for where to find this book, but it's just learnyousomeerlang.com. Okay, so let's start with this unhinged dude. I have no drinks with me today. Okay, is my sound on? Sometimes I start streaming and I realize like I don't even have audio on. It's terrible. Errors and exceptions not so fast. There's no right place for a chapter like this one. By now you've learned enough that you're probably running into errors. We don't make errors, but not yet enough to know how to handle them. In fact, we won't be able to see all the error handling mechanisms within this chapter. That's a bit because Erlang has two main paradigms, functional and concurrent. The functional subset is the one I've been explaining since the beginning of this book. Referential transparency, recursion, higher order functions, etc. The concurrent subset is the one that makes Erlang famous. Actors, thousands and thousands of concurrent processes, supervision trees, etc. Because I judge the functional part essential to know before moving on to the concurrent part, I only cover the functional subset of the language in this chapter. If we are to manage errors, we must first understand them. Note, although Erlang includes a few ways to handle errors in functional code, most of the time you'll be told just to let it crash. I hinted at this in the introduction. The mechanisms that let you program this way are in the concurrent part of the language. Yeah, so in Erlang and Elixir, often if there's errors that come up, you don't actually have to do a million things to try to figure out what's going on and fix it. Instead, you let it crash, and then there's something called supervisor that can restart your process and try to make things back into a good shape. Because usually it crashes when you don't understand what's going on. Your state's probably screwed up. So like trying to continue is a little bit like you ever it's like you're kind of half broken. Your car's half broken. And you're trying to keep run it. It's a lot better just to switch your car, get a new one. That's the analogy. A compilation of errors. There are many kinds of errors: compile time errors, logical errors, runtime errors, and generated errors. I'll focus on compile time errors in this section and go through the others in the next sections. Compile time errors are often syntactic mistakes. Check your function names, the tokens in the language, brackets, parentheses, periods, commas, the arity of your functions, etc. Here's a list of the common compile time error message and potential resolutions in case you encounter them. Module name module does not match the name module. So I already said this somewhere else. When you make a module, like we did um, with any of these, right? Recursion.erl, you notice that the file name and the module name match, and they have to match. Warning, function sum function /0 is unused. Yeah, that's pretty self-evident. Sum function 1 undefined. So you tried using it. Uh, the function you've written the wrong name or arity either in the export attribute or when declaring the function. I'm not sure about declaring the function. Oh, you put the wrong arity when you're declaring the function? This error is also output when the given function could not be compiled, usually because of syntax error. Right, so you didn't compile some function, so something tries to use it and you can't use it. Syntax error before some character or word. This happens for a variety of reasons, namely unclosed parentheses, tuples. So basically this is like lexical error where it's trying to like parse your code and it's like, oh, I did not expect this. It's not correct. So you wrote some syntactically wrong code. Syntax error before, when your line termination not correct. So basically very similar. Warning, this expression will fail with a bad arith exception. Erlang is all about dynamic typing, but remember that the types are strong. In this case, the compiler is smart enough to find that one of your arithmetic expressions will fail, say llama plus 5. It won't find type errors much more complex than that, though. Warning, var is unused, so you declared a variable, but you never used it. This might be a bug with your code, so double check. So sometimes you just have to put an underscore if you know that you're not going to use it, just like I did with duplicate underscore t. I like sometimes keeping it just because it's a reminder of what it is. Warning, a term is constructed but never used. In one of your functions, you're doing something such as building a list, declaring a tuple or an anonymous function without ever binding it to a variable or returning it. So you build something and you know it's going to be garbage collected right away because it's not actually referenced by anything. Head mismatch. It's possible your function has more than one head and each of them have a different arity. Don't forget that different arity means different functions and you can't interleave function declarations that way. So if I have foo like this and I just return like hello, right? And then I have another foo where I'm taking in a variable and I'm returning something like this. I can't go back. Oh, I guess this is kind of hard. Let's do it the other way. I can't go back and, since I switched arity here, I can't go back and have another v when I say when v is like, greater than 10 or something like that. Well, this makes more sense if I did. When v is greater than 10, we do this, and then when I say when v is less than or equal to 10, we do this other thing. Where is less than or equal to this? It might be this. Anyway, that won't work. Oh, I didn't do. I need a function clause here. Okay, so this says function foo with arities 1 and 0 is regarded as two distinct functions, a number of la la la. So it gave you something similar. You can't like kind of mix them back and forth. Warning, this clause cannot match because a previous clause at line 4 always matches. That was sort of the error I had before. Like if I just had this kind of doesn't make sense. It's funny that it says is unused. Oh, probably because I'm just not exporting it. Hey, what? Where's my export thing? What is it like? Export. And you give it a list, right? Fact one, my length one, duplicate two, and foo one. Here we go. All right, so now, oh wow, this doesn't give me an error. It kind of should because this one's always going to match first. Yeah, I don't know why this one doesn't give me an error. Maybe if we compiled it, it would. Yeah, this clause for foo1 cannot match because a previous clause at line 15 always matches. That's this error here. So it does work. Variable A unsafe in case. If you're using a variable declared within one of the branches of a case of outside of it. Ah, this is considered unsafe. If you want to use such variables, you'd you'd be better off. This is a type, guys. We found our first typo. I don't think there's a Git repository for this, right? But it would be cool to submit something. Learn you some Erlang. Learn you some Erlang for great, good GitHub. Oh, maybe there is. 12 years ago, my God. No pull request or anything. So let's see here. Who's the author? Okay, so, oh, but it's not the person who wrote the book. Oh, this is just code. This is not the book. This is probably not it either. Oh, it's just a Git. What the hell? How does this work? Oh, wow. They just have the whole book in GitHub? I didn't know you. Oh, you just put a PDF and that's what this little GitHub will do? Yeah, I don't think there is an actual repository. Too bad. Um, This should cover most errors you get at compile time at this point. There aren't too many, and most of the time the hardest part is finding which error caused the huge cascade of errors listed against other functions. It is better to resolve compiler errors in the order that they were reported to avoid being misled by errors which may not actually be errors at all. Other kinds of errors sometimes appear, and if you've got one I haven't included, send me an email and I'll add it along. Oh, so they'll take email. Maybe we'll send an email with this update. No, your logic is wrong. Logical errors. Yeah, so this sort of thing is interesting. I think it was like actually what language was it recently? Was it Gleam? They were adding like the ability to see multiple errors because sometimes you just get one and it just stops, but sometimes you want to actually fix like multiple of them. It kind of depends on your situation. But sometimes it's actually counterproductive. Like you see 10 errors and like, well, it's the first one sort of caused some syntax error and everything else kind of looks all fucked up. So, um, hey there, Hissim Vault. I used to write our college assignments in Pandoc Markdown and commit their source and renders to GitHub, then submit the GitHub PDF page. That makes a lot of sense, doesn't it? I've been enjoying this whole Mist write up. I have it on my URL too now. So anyone can actually see it at elixir.com for now. Um, yeah, I finally figured out how to get Mist to build the HTML. Not surprisingly, it's Mist space build space minus HTML. Um, yeah. And then I found out about, oh, what is that? Netlify. And so it's doing builds from GitHub. It's kind of neat. I didn't know that existed. And it seems like the free tier goes pretty far for just like hosting and building my documentation. How you doing, Hasim? Logical errors are the hardest kind of errors to find and debug. Yep, that's for sure. They're most likely errors coming from the programmer. Yeah, well, I mean, let's not even read this. If you write code that is buggy, then obviously the logic's going to be buggy, and it's really hard to know where you made a problem. Runtime errors are also pretty destructive in the sense that they crash your code. While Erlang has ways to deal with them, recognizing these errors is always helpful. As such, I've made a little list of common runtime errors with an explanation and example code that could generate them. So we have sort here, and yeah, no function clause matching list. We're trying to pass in an atom here, and sort only is defined for list. It probably has a few guards for sort. All the guards clauses of a function failed, or none of the function clauses patterns matched. Case clause, case something of. No case clause matching unexpected values. So you've made a case here, and something should actually match it, right? Here, this can't match because it's matching an atom. And here it's matching an atom, but we don't have an atom, we have a string. Yeah, I'm enjoying Mist a lot. Ça va? You need something? Chérie, est-ce que tu peux me donner un soda? Quoi? Qu'est-ce qu'il y a? I don't know. Sometimes it's hard to decipher what someone is saying. Um, Merci. I guess it's half service. You get the you get the drink and you have to pour it yourself. You know you're at a good restaurant when like the waiter actually or waitress actually pours the drinks, right? I've been in France, so I spent my youth in the US, and now I've spent enough time in France where if you order soda, they give you a can and you don't get like a little cup or something with it. You're just like, how am I supposed to drink this? And whenever you go to the US, you get a beer or a soda, they just give you the can or the bottle, and often they're like, go figure it out. You can drink from it. How barbaric. So this is kind of interesting, right? Um, let's say it takes in a value, and then we're going to do a case here, um, where the value could be a string. Let's say the string is foo. Um, we're trying to match to foo, right? So this is, whoops. Yeah, that's all we need to do. So if it matches to foo, what is this going to do? Hold on, now I'm confused. It's just going to return foo, right? Yeah. So if it is foo, then we'll return matched foo. What is it, commas? No, I think it's, yeah. And then we have something like something else. This is impossible to match. And now this will fail, right? So if we try to compile this, syntax error before end. Case end. Case of foo matched foo. Something else. Oh, yeah, something else. Oh, the last one doesn't need a semicolon. There we go. Val is unused. True, 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 true. Let's do this. This makes a lot more sense, right? So here we're going to see if val is foo, something, if it matches something else. Compile. That was the recursion file, right? Okay, so now if I do recursion foo and I pass in foo, it says match foo. And if I pass in something else, it says match something else. But then if I do howdy, it has nothing to match it because none of these cases matched. So in this case, we should always have a default one. And I guess what do we do? Is the default like this? Because that'll match with anything. Right? This should match with everything. Okay, let's try it out. Compile recursion. And then we do recursion colon foo. And we pass in just some other atom. Default case, there we go. Okay. Yeah, it's kind of tricky to remember that you have nothing here, and the last one, second to last, has, yeah, I guess I'll remember it. Keeping it consistent with the semicolon just being optional makes much more sense, in my honest opinion. Yeah, right? How you doing, Mecha Pylon? All right, so that was unexpected value. If clause, no true branch. If this, if that, but then we have no default here, right? It's very similar. I don't think it's saying you need a catch-all necessarily. This is just saying it couldn't match anything true. No? Ah, damn it. That's not what I wanted. If 2 is greater than 4, then say okay. If 0 is greater than 1, say okay. End. Yeah, so that's not good, right? But if I did 4 is equal to 4. I guess this is just true. This is just true then. So yeah, they're right. This is just true. We're good. I am really not having an easy time here. All right, let me turn the sound off. It can determine statically that nothing can ever match, I guess? No. Don't think so. If 2 is greater than 10, then say okay. And then I think you don't even need anything else, right? And here we just have to delete this. Foo 0. And now we just call foo. Let's see if that works. Oh, no clause will ever match. You're right. It can tell in this case. It's smart enough to tell. I mean, it definitely has the information when everything is constant here, right? But if I have a variable, now I wonder, now it's dumb. If v is greater than 10, okay, right? So now that's okay. And it says no true branch found. So that's a runtime error. Bad match errors happen when pattern matching fails. Yeah, so that's fine. I think we know what that is, right? No right hand side, no match of right hand side value 3. Bad arg. Looks like probably here this is a runtime error when it has guards and it knows that none of the guards are going to match this. Undefined, no random 1. Usually this probably happens when you have the wrong arity. Oh yeah, or maybe like you didn't export it. Bad arithmetic. Bad function. What is this? Use variables as functions. I see. So this isn't really a function. Bad arity. Anyway, oh, look, why a system, too many processes, atoms are too long, too many arguments in a function, number of atoms too large, just like it's reached its limit. Raising exceptions. In trying to monitor the execution of code and protecting against logical errors, it's often a good idea to provoke runtime crashes so problems will be spotted early. There are 3 kinds of exceptions in Erlang: errors, throws, and exits. They all have different uses, kind of. Errors. Calling Erlang error reason will end the execution of the current process and include a stack trace of the last functions called with their arguments when you catch it. These are the kind of exceptions that provoke the runtime errors above. Errors are the means for a function to stop its execution when you can't expect the calling code to handle what just happened. If you get an if clause error, what can you do? Change the code and recompile? That's what you can do, other than just displaying a pretty error message. An example of when not to use errors could be our tree module from the recursion chapter. Go back to that video if you want to see that. That module might not always be able to find a specific key in a tree when doing a lookup. In this case, it makes sense to expect the user to deal with unknown results. They could use a default value, check to insert a new one, delete the tree, etc. This is when it's appropriate to return a tuple of the form OK value or an atom like undefined rather than raising errors. Now, errors aren't limited to the examples above. You can define your own kind of errors too. I think we did something with, um, yeah, I think it was under tree, right? Let's see what we wrote for lookup. Yeah, so if it doesn't find it, I returned error. Key does not exist in a tuple. And if it does exist, then I say okay. You can define your own error. Bad arithmetic custom error. 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 Foo bar. Exception error, foo bar. Okay, well, that's good. Probably we can make anything in here, right? Yep. Exits. There are two kinds of exits, internal exits and external exits. Internal exits are triggered by calling the function exit1 and making the current process stop its execution. External exits are called with exit2 and have to do with multiple processes in the current concurrent aspect of Erlang. As such, we'll mainly focus on internal exits. So external looks like it's basically like, you know how you send a kill signal somewhere? You probably have to send the PID reference, the process ID, I'm guessing. Internal exits are pretty similar to errors. In fact, historically speaking, they were the same and only exit existed. They've got roughly the same use cases, so how to choose one? Well, the choice is not obvious. To understand when to use one or the other, there's no choice but to start looking at the concept of actors and processes from far away. In the introduction, I've compared processes as people communicating by mail, but no, it doesn't say but. There's not a lot to add to the analogy, so I'll go to diagrams and bubbles. Here's actor A, actor B. A is sending a message to B. Processes here can send messages to each other. A process can also listen for messages, wait for them, and you can choose what messages to listen to. Discard some, ignore others, give up listening after a certain amount of time. So A is sending the hello message to B, and B sends to C a message saying A says hello. These basic concepts let the implementers of Erlang use a special kind of message to communicate exceptions between processes. They act a bit like processes' last breath. How dramatic. They're sent right before a process dies and the code it contains stops executing. Other processes that were listening for that specific kind of message can then know about the event and do whatever they please with it. This includes logging, restarting the process that died, etc. Look, this process A, I'm dead. Damn. Damn, bro. With this concept explained, the difference in using Erlang error and exit is easier to understand. While both can be used in an extremely similar manner, the real difference is in the intent. You can then decide whether what you've got is simply an error or a condition worthy of killing the current process. This point is made stronger by the fact that Erlang error returns a stack trace and exit doesn't. If you were to have a pretty large stack trace or lots of arguments to the current function, copying the exit message to every listening process would mean copying the data. In some cases, this could become unpractical. So, yeah, exit is more about processes dying and being able to communicate their death to people who care, whereas error is more about the function sort of failing and being able to bubble that up so that it will quit and get a stack trace. If you don't really care about sending that over to other processes, I guess you use error. Yikes. Throws. Throw is a class of exceptions used for cases that the programmer can be expected to handle. Okay, so errors are like full on errors. It's bad news. Exit is like error, but with processes and without a stack trace. Throws is like using using it for was a control flow. So you can actually like catch a throw and then decide to do something about it. A throw, la la la. In comparison with exits and errors, they don't really carry any crash that process intent behind them, but rather control flow. If you use throws while expecting the programmer to handle them, it's usually a good idea to document their use within a module using them. I hate this though. Like, I really don't want to see functions where I have to catch stuff in just normally using it. You know, like it's just a pain in the ass. I don't need that extra boilerplate that has the try catch stuff. Oh, I'm tired. Today was a messy day for me. I'm just like I couldn't get started. And then I this word grace is way overused. It kind of is a little cringy, but I was very like I told myself, look, you can't be 100% every day. So I let myself kind of do what I kind of lounge around and whatever. That's why we started so late today. All right, so where are we? Where you can replace permission denied by anything you want, including everything is fine. So let's try throwing it. Exception throw 3. Throws can be used for non-local returns when in deep recursion, right? So if you want to basically do a go-to, you can use throws in a way. An example of that is the SSL module which uses throw as a way to push error reason tuples back to a top-level function. This function can then simply returns that tuple to the user. This lets the implementer only write for successful cases and have one function deal with the exceptions on top of it all. It's kind of a, hopefully you don't have too many cases like that. Other example could be the array module where there is a lookup function that can return a user supplied default value if it can't find the element needed. When the element can't be found, the value default is thrown as an exception, and the top level function handles that and substitutes it with the user supplied default value. This keeps the programmer of the module from needing to pass the default value as a parameter of every function of the lookup algorithm, again focusing only on the successful cases. Yeah, I don't know about that. I mean, like, if you're going to throw anyway, doesn't that mean you're kind of keeping your stack anyway? And then can't that top level stack just hold on to that? And then when it returns, when the function call returns, it's basically going to say, I couldn't find anything. And then you just return the default value. What am I missing here? As a rule of thumb, try to limit the use of your throws for non-local returns to a single module in order to make it easier to debug your code. It will also let you change the innards of your module without requiring changes in its interface. But the good news in these kind of use cases is that they don't expose the throw to the people using their module, right? So that's kind of nice. So how do you deal with these things? You do try, catch, end. So you try to do things, then you catch them. I'm just debating whether or not I want to write examples of this. I sort of hate try catches anyway, so I'm so like inclined to just skip actually testing my knowledge of this. Yeah, here's an example. Anyway, let's just read it, I guess, first. Try expression of. The expression between try and of is said to be protected. So this is like what we're actually trying to do, I guess. This means that any kind of exception happening within that call will be caught. So inside of this expression, it will be caught. The patterns and expressions in between the try of and catch, so these here, behave in exactly the same manner as a case of. Finally, the catch part. Here you can replace type of error by either error throw or exit. For each respective type we've seen in this chapter, if no type is provided, a throw is assumed. So let's put this in practice. Okay, let's just try this out. So they're basically saying this is the protected thing, right? That's in between try and of. So that's the function that should like possibly throw something. Um, and then these is basically like just like your case of function. So this expression, if it returns the number 1, then if this is 1, it's going to match this one, right? Probably you don't need anything here. I'm guessing, like, I don't think. Well, let's just fucking write this code. Let's just write it. Stop complaining and we'll write it. Okay, buggy code. This is a function that takes in some parameters. Let's just take in one parameter, and it's going to do, what's it called, IO format? Yeah. Got X P N. Wow, I hope, did I actually remember this stuff? Okay, so first we're just gonna do this. We have to, ah, all right, so, oh, I put it in tree. This is unfortunate. It doesn't matter. And we'll do it here. We'll just, okay. Earl. And then we'll compile tree. And now we call tree buggy code. We pass 10, and it says got x 10. And if I pass in a list, oh, please stop killing me. It said got x 10 comma 1, right? This is printing out the object in whatever native format, I guess. It's kind of like JSON stringify or whatever. But now we're going to throw. Here we go. This is our throw. Semicolon? I can never remember with this language if it's semicolon. It must be semicolon. Nope. What is it? Throw something. Oh, I need. Am I writing Haskell now? All right, there. I'm throwing an error. And let's try to see if this compiles. Let's try running buggy code. Exception throw my error 10 comma 1. So you see we got an error, and it tells you we got my error, and it passes you whatever. Maybe that's the reason or something we're not happy about. So now we're going to make a function that uses this buggy code caller. um, so we do, what was it called? Was it try? Try, we pass buggy code something of, and buggy code could return something, right? Let's say if it's if it returns okay, then we say returned okay. This won't match currently. And then we do catch, and we have to catch the error. Caught my error with value. Oh, I don't know how to concatenate strings. Maybe it's plus plus. I think it's plus. Yeah, it's just a list. I hope that works. I don't know if I have to change it. And then catch anything else. We can say unknown throw. And maybe end. Okay, this doesn't, it's not happy with this. Maybe this is semicolon. Yeah, that looks better. Buggy code caller. Looks like it's happy. Now we try to compile this. And now we do buggy, tree buggy code caller. And we didn't give it any, no parameter. Got x1. What? What just happened? What just happened here? Ah, this is the ASCII code. That's why. So how do I interpolate this into this thing? Let's just print this out. This will make it easier. No, why am I being silly? Just make this a tuple. There we go. So it's going to return a tuple caught my error x. There we go. Caught my error 1 because x is 1. And obviously if we change this to something like a list, caught my error 1, 2, 3, the list. Function living up to its name. Sure is. Like when I saw this, I was like, what the fuck this, but then you know what this is, right? This is the ASCII for for the caught my error, and then this is the one at the end. But because of the one, it it becomes a list because one is not a printable string character. All right, so does that mean we can skip all of this? Oh, one thing I wanted to try was, do I actually need to have anything here? Yeah, it's kind of weird, right? It looks like you can, I guess you can just do this. Whoops. Yeah, it looks like we can do this. And this will compile. I was just trying to figure out, like, do I actually need anything in this try between try and catch? And um yeah, it's kind of funny because in Elixir you can do something like this, and then you can just return foo. Looks like you can do the same here. Except we'll never get there because no, we will, right? Because it returns this, and then it ends and it'll return foo. So it should return. I don't know what this does. Yeah, I guess it goes in here, and then it returns. I see. It's going to return this. That goes to foo. So now I can do something like foo comma 1. And now if I run this, yeah, put it in another list and added 1 to it. So looks like you can actually assign it to the return value of this try. Okay, God, we got through that really annoying part. Throw, slice. Wait, what is going on here? Where do they make the sword function? Oh, this is just a literal. Sword 1 is going to throw slice, which is, this feels so artificial. I'm just going crazy. Like, I'd rather it say foo bar. Sword 1, I see. This is almost like, yeah, this is like a dice roll, right? 1, 2, 3, 4, 5. It's going to match based on the literal. So it can either throw a slice, error, cut arm, exit, cut leg, throw a punch, exit, cross bridge. And then you have Black Knight attack when is function attack, comma 0. Probably this is the arity for is function. Term arity, yep. Don't they have like some kind of like help? They had something. Whoa, that was info. All right. That doxed me for sure. You guys figured out I'm a super carrier now. Okay, let us like just ignore all of this because this is boring. Finally, so there's an after that you can put in also. Which is probably mean, yeah, so it's going to execute if any of the catches, and then it's going to do after, so you could like clean stuff up if you have to. Therefore, after is mostly used to run code with side effect. Yeah. File you were reading gets closed, blah, 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 blah. We now know how to handle the three classes of exceptions in Erlang with catch blocks. However, I've hidden information from you. It's actually possible to have more than one expression between try and the of. Oh my god, look at this. Yeah, when it said expression, it could probably be multiple. Which means like here, we could do try of, and then in this try, we can do buggy code. We can do something else like 1 plus 1. I don't know what else to do. IO format again. Oh, I guess we can't do that. Is float. Oh, maybe we could do 1 plus 1. There we go. Yeah, that's valid. Okay, so we have, but let's put the buggy code in the bottom. Okay, so this should execute, and then we're going to throw here, and then we'll go through whatever, and then it'll catch here and do all this stuff. Result of is ignored. Yeah, that's fine. Let's fix it. Okay, now it's happy. And now I can do tree. What's it? What do we call it? Buggy code caller. And it doesn't take any parameters, right? Hello world got X. So we did get here. I guess I should put in the new line, right? There we go. So it did call hello world here. And then we call buggy code and it's printed out got X. So we got here. And then we throw. This throw gets matched here. So it should say caught my error X. It doesn't print it. It just returns it. And then we add it in a list and add 1 to it. So that's why we have caught my error this. And then we put it in a list and we add 1 to it. Does Erlang have expression statements distinction of languages like C? No, everything is an expression. So I don't think there's anything where, or like in JavaScript, something you have to do return. Everything is a value. Just like most functional languages, Erlang is functional language. So yeah, I can't think of a functional language. I don't know that many, but Scheme, Haskell, Lisp, Elixir, everything's an expression. I have an idea for a Nerves project. I want to Elixir Nerves, which is like the embedded systems programming system for Elixir. I want to I bought a Commodore 64, the Commodore.net, you know, Commodore.net. They're relaunching this. So I bought one, but it comes with the old ports. You see here, let me show. That's the joystick ports. I think this is a cartridge port. One of these is like maybe an S video and the other one's IO port. The other one, I don't know. Anyway, serial ports, printer ports, whatever. I was thinking of writing like something that will connect those pins to a Raspberry Pi using Elixir nerves, and maybe acting like can you imagine if it like was talking its printer protocol, but then it connects to my little Raspberry Pi and then it prints on a regular printer? That would be just cool. I don't know what else I could do, but got to figure something out. Anyway, I figure it can't be that hard, right? Last words, last words. Um, yeah, I don't know what. It's important to know what the protected part of an exception can't. It's important to know that the protective part of an exception can't be tail recursive. The VM must always keep a reference there in case there's an exception popping up. Because the try-catch construct without the of part has nothing but a protected part, calling a recursive function from there might be dangerous for programs supposed to run for a long time, which is Erlang's niche. After enough iterations, you'll go out of memory of your program, will get slower without really knowing why. By putting your recursive calls between the of and catch, you are not in a protected part and you will benefit from last call optimization. Some people use try of catch rather than try catch by default to avoid unexpected errors of that kind. Okay, so I skipped something where they did a try catch without an of. What? Where? What? Help me out here. This is. Oh, here's the try catch. So this is basically doing what I said, where I left the of in here, right here. Let me bring that up. And I was like, oh, can I just like do this? No, you can just remove this. Um, and apparently that'll compile. Yep. So you only need the of if you're actually caring about the value. And it's saying don't put anything in the protected part, which is between the try and the of. That is tail recursive. How do you say that? Tail end recursive? Tail recursive optimized? I can't speak English anymore. Uh, right, because it's going to make it so it's not tail recursive and it's going to just keep like growing on the stack. Putting a little Pi live translator to bridge the time gap sounds fun. Yeah, I got to figure that out. Wait, there's more. No, please, no more. I'm done with this. As if it wasn't enough to be on par with most languages already, Erlang's got yet another error handling structure. That structure is defined as the word catch and basically captures all types of exceptions on top of the good results. It's a bit of a weird one because it displays a different representation of exceptions. What the hell is this? Catch, throw, whoa, whoa, catch. So it's just saying it catches everything, right? Interesting. So you could just like put catch in front of any expression. There's no like is list. True. Tree buggy code. It needs a value. My error one. So Notice the difference, right? Tree buggy code 1 on its own, you see the exception throw, which basically the shell or the REPL got it. But when I did catch, it's like, yeah, we're good. What we can see from this is that the throw remains the same, but that exits and errors are both represented as exit reason. That's due to errors being bolted to the language after exits. I see. So if this were happening due to an exit, it'll look different. Yeah, so it'll print out exit and then give you the reason, which is the parameter passed in. I'm going to skip trying to parse this right now. Catcher. Oh, interesting. You're looking for the exit path. This is basically annulling the throw. You have to be careful with its precedence. All right, I've had enough of this. I've really had enough of this try catch thing. Nope, not doing it. I don't like doing it like this, so I'm not going to do it. But I think we get it. What is an Amstrad? I think it's a you know about it? Vieille console? Like video game? Here it is. Look at that. So it looks like an 8 or 16-bit home computer. Mostly in the UK, I'm guessing. Was launched in UK, Ireland, France. Oh, so it was here too? Oh, so wait, it got the ZX Spectrum. Wait, I'm so confused. So Amstrad took over Sinclair? Then why did they have their own Amstrad if there was kind of crazy? Did I mention that I bought like one of those repros of the Sinclair Spectrum? Let me find it. The Spectrum. I haven't opened it yet, literally. But I think it's supposed to be like what do you call it? Like full keyboard that works. But yeah, the Specky kind of has like a bad keyboard, so sounds kind of annoying. I have like a what is this? Can you see that? It's I have a video capture card, so I think I should be able to stream like trying to run this thing. I'm kind of curious, like because this is running a Zilog 80 CPU, right? I don't know anything about that CPU. I kind of heard good things, like it's on paper it's good, but like that when you actually program assembly on it, has lots of issues. It's a little harder for some reason. Maybe because of like the graphics timing. Throw some of this stuff out, right? Oh, I thought you were done. All right. I think we're done with this chapter. It can be put away. uh, I find that throw, catch, and errors and all that kind of stuff, like, they're never hard to really use. You just sometimes, I just have to look it up because it's not something that I use all the time. Yeah, there's so many things that sound like fun. The problem is like I can't do everything I want to do. It's incredible. Good time to live though, I guess. Let's just like glance at what this next chapter is going to be, but we're going to stop. But I just want to set my mind. Functionally solving problems. It sounds like it's not going to be much about the language. It's more about like how to just more programming stuff. Maybe this is good because it gets us, just using the language. If you don't use the language, you're just going to forget stuff. You never know if you really learned it, right? So this must be reverse Polish notation. Um, yeah, so it's like kind of like a stack 3, 5, and then plus is the operator. Yeah, maybe this could be fun to write. Try catch. Don't. Heathrow to London. Heathrow's the worst airport ever. It's the only airport where I ever missed a connection. It's just too big and it's like just seems really like often you got to take a bus to go from one terminal to another. What a pain in the ass. You're on a plane due to land at Heathrow Airport in the next hours. You have to get to London as fast as possible. Your rich uncle is dying and you want to be the first there to claim dibs on his estate. Oh my god. I usually take the tube from Heathrow to London, and that is a long ride. But it's kind of like Zen chill out. You're above ground a lot of the way. What is this? Is this A-star algorithm? I'm surprised if we do that. Um, Whoa, this feels like you're doing Advent of Code, right? Actually, maybe we should do Advent of Code with Erlang. That could be cool. So that was like not at all this was not at all like any new programming concepts that I could tell. And this next one, a short visit to common data structures. Yeah, so this is new again. I'd be almost tempted to skip to this. Because then we get into maybe some data structures that we need. And now we learn about concurrency, so probably we're making like, whoa, this is not like programming. It's, oh, here we go. Spawn. So it spawns a process and it runs function f. I'm guessing, right? Spawn. Let me try to remember the syntax. Spawn, and then I think you give it the parameters like this. And then we can return in function, we'll put x here. I think you type end. Ah, bad arity. Oh, because spawn functions can't have any values. That's why. We'll just do this. It does it, but I can't get the value. Here, what I can do is have something that doesn't has an effect. io.format in function, right? There we go, you see. So it spawned a function, it spawned a process and ran this function. I wonder how you sleep in Erlang. Where's sleep? Come on, I just wanted the sleep function. No, I don't think that's what it is. It's probably process. Is there something called process? Okay, we'll just do something stupid here. Time. Oh, it is time or sleep. One, two, three. Boom. In function. One, two, three. Boom. In function. All right. So there we go. That's how we know it's a real process. I have been thinking about. Oh, wait. Okay, first of all, let's get rid of the spammer. I have been thinking about how to get data out of the old thing. Your Pi idea might be the simplest. I've also considered transferring data through the built-in speaker buzzer. Oh my god! Low bit rate, obviously, especially if I need to code a trivial transmitter into volatile memory before each use, but each diskette doesn't hold much data. Are you talking about something that can pull data out of floppy disks and put it into modern storage? So, yeah, so that's interesting. It's an interesting problem. You basically want to archive your very degradable materials, magnetic disks and such, into something that will last longer. And obviously stuff that you can move around more easily. You would your Amstrad, I assume, has a disk drive, right? The tape drive probably you're not talking about tapes because tapes, I assume, are easier to copy because they're just sounds, right? Like you could probably just, I mean, it's a fun project, but you could probably just like decode the sounds and turn that into the right data. Just use some test data sets to make sure that it does it right. But the disk is funny because yeah, you need the drive that building a disk reader wouldn't be feasible, I would think. Instead, you'd want to use its hardware and then once it loads it in memory, So you almost want like to make the disk copier utility on the PC that just loads a sector or whatever and then transmits it back over some port. You could send it over yeah. So if you made like a little Raspberry Pi integration, it would just need to speak a protocol that that computer could understand, right? Assuming like some serial IO protocol or something like that. That would be fun to learn. Um, Pretty useless, as in like you wouldn't use that protocol. You know, who knows? Maybe somebody probably has code that does it. So you could probably use that code and just wire up your Raspberry Pi to do it. That would be fun. Anyway, I'm going to oh crap, I think I have a meeting. So I got to run. Talk to y'all later.